This is Bob Capetta from the College of the Florida Keys, and this lesson is on synthetic division. If we're given a problem like this, we could try to factor it, maybe, or we could use polynomial long division. But this is a special case that enables us to use synthetic division. We just have a binomial downstairs with an x value and a number, and the coefficient on the x value has to be 1. So x minus 2 fits the requirements for synthetic division. 5x minus 7 would not. X minus 3 would fit. X minus 4 would fit. X plus 1 would fit. As long as the polynomial on the bottom is a binomial with an x and a number, it can work, as long as the coefficient on that x is 1. So here's what we do. It's x minus 2, so we put the 2 outside in a little bracket. We read the coefficients in order. X cubed, x squared, x number. Nothing is missing. We have all of them. We write them in order. 3 is the x cubed coefficient. Negative 11 is the x squared coefficient. 12 is the x coefficient. Negative 4 is the constant coefficient. Next, we bring the first number down. 3 drops down. Then we multiply this outside number by the down number. 2 times 3 is 6, and that goes in this slot. Then we add these together. Negative 11 plus 6 is negative 5. Multiply again. 2 times negative 5 will be negative 10. 12 plus negative 10 is 2. 2 times 2 is 4. Negative 4 and 4 is 0. That is your remainder. So there is no remainder. My quotient is defined by the coefficients 3, negative 5, and 2. This is the constant, this is the x, and this is the x squared term. So that represents 3x squared minus 5x plus 2, and that's how we were able to quickly do that. But again, this method only works if you have x minus a number, 1x minus a number. So please keep that in mind as we look at our other examples. So our next one is not x minus something, it's x plus 3. But we can think of x plus 3 as x minus negative 3. If that's the case, then the negative 3 goes outside. I have coefficients of x squared, coefficient of x, and a constant coefficient, so nothing is missing. So negative 3 goes outside. The coefficients of 2, negative 1, and negative 17 create our original step here. Then we bring the 2 down. The first term always comes down. Then we multiply. Negative 3 times 2 is negative 6. Negative 1 plus negative 6 is negative 7. Negative 3 times negative 7 is positive 21, goes in this slot. 21 minus 17 is 4. That's a remainder. So what we have is we have coefficients of 2 and negative 7. This would be the constant term, this would be the x term. So this represents 2x minus 7 with a remainder of 4. And it's good to write the remainder over the divisor, so that would be 2x minus 7 plus 4 over x plus 3. So that's how that one works. Our next example, we have x cubed minus 27 over x plus 3. Remember, the bottom has to be x minus something. So x plus 3 can be thought of as x minus negative 3, so that's okay. The top, though, is missing an x squared term, and it's missing an x term. So we're going to add zeros in so that we have a properly defined exercise. X cubed plus 0x squared plus 0x minus 27. Now we have 1 is the coefficient of x cubed, 0 is the coefficient of x squared, 0 is the coefficient of x, negative 27 is the constant coefficient. And it's x minus negative 3. That negative 3 goes outside. And here's our coefficients of 1, 0x squared, 0x minus 27. The first step is to bring the initial coefficient down to the bottom row, then multiply negative 3 times 1 to get this number. Negative 3 times 1 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is positive 9. Positive 9 goes in this slot. 0 plus 9 is 9. Negative 3 times 9 is negative 27. Now be careful. Negative 27 plus negative 27 is negative 54. That's our remainder. So looking at our quotient, starting on the right side, this is the constant term, 9. This is the x term, negative 3x. This is the x squared term, 1x squared. So these three coefficients mean 1x squared minus 3x plus 9 plus negative 54 over the divisor over x plus 3. Or if you prefer, x squared minus 3x plus 9 minus 54 over x plus 3. That would also be acceptable. All right, let's do one more problem. I've got 2x to the fourth minus 13x cubed plus 23x squared minus 5x minus 28 all over x minus 4. Again, notice the bottom is x minus something, 1x minus something. That's when you want to use this strategy. If your divisor is something other than 1x minus something, then you want to use polynomial long division. So 4 will go on the outside since it's x minus 4. Coefficients of 2, negative 13, 23, negative 5, and negative 28. Nothing is missing, x to the fourth, x to the third, x squared, x constant. If something is missing, we've got to put in a 0. First thing we do is we bring the initial coefficient down to the third row, and then multiply. 4 times 2 is 8. 8 goes in this slot. Negative 13 plus 8 is negative 5. 4 times negative 5 is negative 20. 23 minus 20 is 3. 4 times 3 is 12. Negative 5 plus 12 is 7. 4 times 7 is 28. Negative 28 and 28 is 0. So there's no remainder in this situation. So what we're left with is our quotient. 2, negative 5, 3, 7 represents the quotient. 7 is the constant term. 3 is the x term. Negative 5 is the x squared term. And 2 is the x cubed term. So that our quotient will be 2x cubed minus 5x squared plus 3x plus 7. And that will conclude this lesson.